Okay, so we've got strontium-90 isotope emitting beta minus particles and decaying to form the stable isotope of yttrium-90. Now, explain without calculation why the kinetic energy of the beta minus particles released when the strontium nucleus decays varies from 0 up to a maximum. Alright, so let's jump across and let's just write down what's going on. So we've got strontium-90 is actually decaying into yttrium-90, and it's going that through beta minus decay, and as you know that means it's also going to be emitting an anti-electron neutrino. Now, oops, there we go. Now, what's actually going on in more detail, if we think about it, really, is it's only really affecting one. In terms of change, one neutron. So you've got one neutron is actually converting into a proton because it's emitting a beta minus particle and an anti-electron neutrino. Now, what's actually happening is quite a bit more than this. So that neutron itself has probably got some kinetic energy, and the proton is probably going to end up with some kinetic energy. The beta particle plus some kinetic energy, and the alpha electron neutrino obviously has got some kinetic energy as well. So, whilst the decay meets all the conservation laws in terms of lepton number, etc., 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 we also have to obey the conservation of energy. So, there are effectively kind of two extremes we might consider here. So we're going to consider two scenarios. And what we're going to say is, well, there's a scenario whereby the neutron and any kinetic energy that neutron actually has, and what it's going to end up doing is just putting all of that into the proton. So this is, so you've got the proton, the beta minus, plus the kinetic energy of the beta particle, plus the anti-electron neutrino. So these are effectively just the rest energy. And there again you've got your rest energy. Here the beta minus is obviously its rest energy, but now this has got the maximum kinetic energy it could have. Because all of the kinetic energy over here, plus the energy released during the decay, is actually ending up being in the kinetic energy of the beta particle. So the opposite kind of that scenario is, again, you've got the neutron, plus whatever kinetic energy it's got initially, is going to be then converting across to the proton, plus kinetic energy of the proton, plus the beta particle, plus the alpha electron neutrino, plus the kinetic energy of the alpha electron neutrino. So in this case what's actually happened is the beta minus has got no kinetic energy. All the kinetic energy from the initial energy the neutron had, plus energy released in the reaction, has ended up going to either the proton or the anti-electron neutrino. Well, I should say, when I say the proton here, obviously, it could actually be the nucleus that the proton is associated with. So this shows us then basically how the energy of the beta particle released as the strontium is decaying can either end up as a very maximum value or could actually end up as 0. I hope that helps. Thank you very much.